Hi, welcome to my channel Mathematics Made Easy by Mary MJ. Today I am discussing class 11 chapter 13 limits and derivatives. We have already discussed the part limits. Now we are moving on to derivatives. So let us consider the function y is equal to f of x. That means when x changes, y also changes, or if when x varies, y also varies. So when x varies, y also changes. This we have already discussed in the second chapter. So let us take one example, that is f of x, let it be 2x plus 2. When I am giving value for x, corresponding change will be there in f of x or y. So let it be x and y. Let x equal to 0. So what happens to the value of y? Y is equal to 2. When x equal to 1, 2 into 1 plus 2, that is 2 plus 2, that is 4. So when x is changing, y also changes. So that is here rate of change of y. How much y is changing with respect to x, that we call it as dy by dx. So the rate of change of y, how much it is changing with respect to x, that is called dy by dx. Dy by dx, and that is rate of change of y with respect to x. That is called, and this process is called differentiation. So what is differentiation? Rate of change of y with respect to x. This process is called differentiation. So what is derivative, and what we are getting, that is output, is called the derivative. The output after differentiation is called derivative. So we'll take a real life example, that is, let it be throwing a stone. So I'm taking one example of throwing a stone. Example, throwing a stone. So when I am throwing a stone, I am drawing the distance time graph here, and the time this side and distance this side. So when I am throwing a stone, when the time is changing, here at 1 second, suppose the stone reaches here, this is 1 second. So the distance, it is this point. Then if it is 2 seconds, stone reaches here. So the distance changes with respect to time. Distance is changing with respect to time. Here distance changes with respect to time, and that we can write it as distance is s, so ds by dt. Distance is changing with respect to time, we call it as ds by dt. So when here time is 1 second, distance is this much, and time is 2 seconds, accordingly it is changing. So distance changes with respect to time, that we denote it as ds by dt. So actually that is called differentiation. That is the rate of change of y with respect to x, or distance with respect to time. So accordingly. Okay, now how to represent the derivative. Next we will study how to represent. That is representation of derivatives. Representation of derivatives. Let the function y is equal to f of x. So we can represent the derivative as either we can write it as y dash, or we can write it as f dash x. F dash x means also it is a derivative, or we can write dy by dx, or we can write it as d by dx of, instead of y we can give f of x, or we can write it as d means derivative of f of x. These are all ways we can represent the derivative, y dash or f dash x, or dy by dx, or d by dx of f of x, or d of f of x. And at some particular point, let it be at x equal to a, what is the derivative? So we can write it as dy by dx at x equal to a. When the value of x is a, we have to find out the derivative, means that we have to write there at x equal to a. Okay, so that is at x equal to a. Now how to find the derivative? How we can find out the derivative? That is, derivative means, as I have told you, that is f dash x or y dash or dy by dx. This we can write, you can find out using the formula limit h tends to 0 f of x plus h minus f of x divided by h. So that is a difference in f of x and f of x plus h divided by h. H means a small increment. So that derivative, that no need of studying the how we are getting this formula. No need of studying that. So only you have to study this formula, and this method we call it as first principle method. First principle method or first principle derivative. So that how we are getting this formula, it is not asked or not given in the textbook. If you want, I can discuss, but it is not used anywhere in your exam. It is not exam oriented. Only you need to study this result. This method we call it as first principle. So using first principle method, how to find out the derivative, that is a way of asking questions. So you have to study it in that form. So I'll show you how to find derivative using first principle. So first principle method of finding derivative. So we'll take one example. Find the derivative. Find the derivative of f of x equal to 10x using first principle method. So how you have to find? F dash x equal to limit h tends to 0 f of x plus h minus f of x divided by h. That is the formula in order to find using first principle method, and that is equal to limit h tends to 0. F of x is given as 10x. So what is f of x plus h? Instead of x, we have to replace it by x plus h. So 10 into x plus h. Where x is there, that we have to write it as x plus h. So f of x plus h is 10 into x plus h minus 10x whole divided by h. That is equal to limit h tends to 0. Here open the bracket. So bracket opening 10x plus 10h minus 10x whole divided by h. Then next what we can write there, we can simplify that. That is 10x and minus 10x getting cancelled. We can write it as limit h tends to 0 10h by h, and that is equal to h can be cancelled and the answer is 10. So derivative of 10x is 10. So d by dx of 10x is equal to 10. That is what we have got it now. Then next one, using first principle method itself, we will do the next question. Another example. Find the derivative of f of x equal to x square using first principle method. Using first principle method. So f dash x, first we have to write the formula. F dash x equal to limit h tends to 0 f of x plus h minus f of x whole divided by h. That is equal to limit h tends to 0. F of x is x square. So what is f of x plus h? Instead of x, it is x plus h. So x plus h whole square. So instead of x, it is x plus h. So x plus h whole square minus x square whole divided by h. That is equal to limit h tends to 0. Now expand x plus h whole square using a plus b whole square. That is x square plus 2 times x into h plus h square minus x square whole divided by h. Now that x square and minus x square getting cancelled. Remaining limit h tends to 0. H is common here. That h we can take it out. Remaining 2x plus h whole divided by h. That h can be cancelled and give h tends to 0 here. We are getting the answer as 2x. We are giving h as 0. H tends to 0 means h will be given the value as 0 and the answer is equal to 2x. So we got that the derivative of f of x equal to x square is 2x. That how can I write d by dx of x square? Derivative of x square is equal to 2x. That we got it using first principle method. Okay, now next one. Next question. F of x equal to 1 by x. So a formula in order to find out f dash x is limit h tends to 0 f of x plus h minus f of x whole divided by h. That is equal to limit h tends to 0. Instead of f of x plus h, it is 1 by x plus h minus f of x is 1 by x whole divided by h. Then now how can we simplify this? That we can apply, we can multiply, cross multiply here. That is limit h tends to 0, cross multiplying x minus x plus h whole divided by x into x plus h. By h means that also it is coming in the denominator, so we can write h here because it is h by 1 taking the reciprocal 1 by h. So this h also is coming in the denominator. Now opening the bracket, limit h tends to 0 x minus h by x into x plus h into h. X and minus x getting cancelled, remaining limit h tends to 0 minus h by x into x plus h into h. You can see here in the numerator and denominator h is common, that can be cancelled. Remaining limit h tends to 0 minus 1 by x into x plus h. Here again we can apply the limit, that is give h as h tends to 0 here So what happens? Minus 1 by x into x is minus 1 by x square. So what we got? Derivative of 1 by x is equal to minus 1 by x square. Derivative of d by dx of 1 by x is equal to minus 1 by x square. Now same way we can go for trigonometric functions also. How can we find the derivative of trigonometric functions using first principle method? So that is, we'll find the derivative of f of x equal to sin x using first principle method. So we have to find what is f dash x. F dash x equal to limit h tends to 0 f of x plus h minus f of x whole divided by h. That is equal to limit h tends to 0. F of x plus h means it is sin of x plus h. Instead of x, it is x plus h minus sin x whole divided by h. Now what is sin a minus sin b? Sin a minus sin b, according to our trigonometric results, sin a minus sin b is 2 cos a plus b by 2 into sin a minus b by 2. So here instead of a it is x plus h, instead of b it is x. So this can be written as limit h tends to 0 2 cos a plus b, that is x plus h plus x by 2 into sin x plus h minus x by 2 whole divided by h. Now we have to simplify this. That is equal to limit h tends to 0 2 cos x plus x is 2x plus h by 2 into sin, here x and minus x will get cancelled, remaining h by 2 whole divided by h. Now this 2 we can bring it to the denominator. How can we write this 2 word? We can write this 2. This 2 we can write it as h by 2, because taking the reciprocal, that 2 will come in the numerator itself. So this is equal to limit h tends to 0 cos, this we can divide it and write, that is 2x by 2 is x and h by 2 into sin h by 2 divided by, here already h is there, this 2 I am taking to the denominator, h by 2. So if you are taking the reciprocal, it comes in the numerator itself. Now we can apply the limit. As we have already studied, if sin comes, in order to apply the limit, what it is there here, that is sin of h by 2, denominator also same thing should be there. Here already sin h by 2 and here also h by 2 is there. So we can apply the limit. So this is equal to limit, separately I am applying the limit for this and this. Limit h tends to 0 cos of x plus h by 2 into limit h by 2 tends to 0 sin h by 2 by h by 2. So this part we have studied, limit x tends to 0 sin x by x is equal to 1. Same way here also, limit h by 2 tends to 0 sin h by 2 by h by 2 is equal to 1. So this part is 1. So the answer, limit h tends to 0 cos of x plus h by 2 into 1. Now here if I am giving limit, that is if you are putting h as 0, the answer you can write it as cos x. So f of x equal to sin x, its derivative is cos x. Derivative of sin x is cos x. So how can we write that? D by dx of, that is d by dx of sin x is equal to cos x. So we got it using first principle. Derivative of sin x is equal to cos x. Okay. Now next one. Next we are going for f of x equal to cos x. F of x equal to cos x. So f dash x equal to limit h tends to 0 f of x plus h minus f of x divided by h. So same way as the last one, limit h tends to 0. Instead of f of x plus h, we can write cos of x plus h minus cos x whole divided by h. Now our identity, cos a minus cos b is minus 2 sin a plus b by 2 into sin a minus b by 2. So limit h tends to 0. So cos a minus cos b is equal to minus 2 sin a plus b by 2 into sin a minus b by 2. So here also applying cos a minus cos b is minus 2 sin a plus b by 2, that is x plus h plus x by 2 into sin x plus h minus x by 2 whole divided by h. That is equal to limit h tends to 0 minus 2 into sin of x plus x is 2x. 2x plus h by 2 means it is x plus h by 2 into sin x and minus x getting cancelled, remaining h by 2 whole divided by h. Now as earlier, this 2 we can bring it down to the denominator, and so that it becomes h by 2. So this is equal to limit h tends to 0 minus 2 sin, that 2 we can write in the denominator. This 2 we can write in the denominator. So sin of x plus h by 2 into sin of h by 2 divided by, here h is there, this 2 comes to the denominator, so that is h by 2. And now applying the limit, this is equal to limit h tends to 0 minus sin of x plus h by 2 into limit h by 2 tends to 0 sin h by 2 by h by 2. So this part it is 1, and here giving h as 0, we will get it as minus sin x. So in the next line, as the next step, we can write it as, this is equal to minus sin x into 1. This part is 1, and here giving h tends to 0, here only minus sin x, and the answer is minus sin x. That means the derivative of cos x is equal to minus sin x. So today we discussed few of the, in this video we discussed few of the derivatives. Derivative of sin x is cos x, derivative of cos x is minus sin x, derivative of x square is 2x, derivative of 1 by x is minus 1 by x square. Now in the next video we'll continue with this. Thank you for watching my video. Those who haven't subscribed, please like, share and subscribe, and also click on the bell icon for more updates and notifications. Bye.